All right, guys, we're in chapter 12, section 3. We're doing geometric probability. Geometric probability right here, here's the definition. It uses ideas about area to find the probability of an event, okay? I know that probably is like gibberish to you. So let's kind of look at a little bit of example right here. Here is possibly something similar to a dartboard, except it doesn't have the bullseye in the middle. So what a question that I would give you would be like, what is the probability that you throw a dart at this board and it lands in the red region, okay? So you're gonna set it up as a fraction, okay? The bottom portion of your fraction, okay, is your entire thing. It could hit any part, okay? I said, what's the probability of it hitting the red? Okay, well, the bottom portion of your fraction is the probability of it hitting anything, okay? You have to count up how many sides there is, red and white. There's 10 total, okay? How do I know that? There's 5 red, there's 5 white, there's 10 total, okay? That's the bottom part of your fraction. Now, the top part is what I'm looking for. What's the probability of it hitting a shaded region? How many pieces are red? 1, 2, 3, 4, 5. So our fraction will be 5 over 10. Well, 5 over 10 is not simplified. We can simplify 5 over 10 down to 1/2, okay? Let's look at example 1, okay? In the figure at the right represents a dartboard, okay? Find the probability of landing in the shaded region. If you throw a dart, it's got to land in this little T right here, this shaded region, okay? Well, if you look in your book and you count every single one of these blocks, there's 64 total, okay? 64 is the bottom part of our fraction. Now we count up how many boxes there is that are shaded in this purple pinkish color, okay? There's 18. So our fraction is 18 over 64. There's an 18 over 64 chance that you throw a dart and it lands right here, okay? Now, people don't say 18 over 64, okay? So that tells me that we can simplify 18 over 64 a little bit. I know 2 goes into 18. I know 2 goes into 64. And if we simplify it all the way down, we're going to get 9 over 32, okay? Now let's check out B in example 1. Suppose you throw 50 darts. How many would you expect to land in the shaded region? Okay, well, now they've kind of changed the question up on us. They're saying, okay, you're not just throwing 1 dart, you're throwing 50 darts, okay? And then it's saying, how many of those darts that you threw do you think would land in the region? So we have to set it up just a little bit differently, okay? We still have our fraction right here that we simplified all the way down, okay? We have 9 over 32. We're going to set what we're looking for equal to 9 over 32, or we could set it equal to 18 over 64. It doesn't matter. But 9 over 32 is our simplified fraction. So we got 9 over 32. We have it set equal, okay? Now here is where we have to remember how we set our fractions up, okay? So we threw 50 darts, okay? That's the total number of darts. Now we're looking for how many darts hit, okay? So 50 is going to be our bottom number. That's our total. And we don't know how many darts are going to hit. So we're going to set it equal for a variable. We could set this variable as A, B, C, D, E, whatever. The book chose N. Okay? So they got N over 50 equals 9 over 32. 9 over 32 is the entire board. N and 50 are our darts that we're throwing. Okay? The next thing they did, they cross multiplied. N times 32 is 32N. 50 times 9 is 450. That 450 equals 32N. They divided by 32. They got N equals 14.1. So if you throw 50 darts, you got a chance of 14, a little over 14, hitting this T right here, okay? That's your example problem. Don't worry about example 2. If you will do the example problems, they're exactly like example A, and they're exactly like this one that we did earlier, okay? Good luck. Let me know if you need any help.